Welcome to the Discover Bittensor podcast. My name is Nick, and the objective of this podcast is very simple to help normal people understand Bittensor. Today, we're going to zoom out a little because in the previous episode, I talked about the big idea behind Bittensor. The idea that artificial intelligence might not only be produced inside companies, but inside an open network. A network where participants contribute machine intelligence, where the network evaluates usefulness and where economic incentives reward the most valuable contributions. In other words, an attempt to create a marketplace for intelligence. But once you hear that idea, a natural question appears: what does this system actually look like? If you could zoom out and observe Bittensor from above, what would you see? What is actually happening inside the network? And why are some people convinced that this architecture could become extremely important? To answer that question, we need to stop thinking about Bittensor as a piece of software and start thinking about it as something else entirely: an ecosystem. And to make that ecosystem easier to visualize, I want to introduce two mental models today. The first is a forest, the second is a planet of cities. Both describe the same system, just from different angles, and together they reveal the shape of what Bittensor is trying to build. So let's start with a little thought experiment. Imagine a distant planet, a rocky, empty planet. There are no cities, there's no life, no ecosystems. That planet represents Bittensor at the very, very beginning. The protocol exists, the rules exist, but nothing has been built yet. No services, no applications, no activity. Just potential. And then something interesting begins to happen. Small experiments appear, tiny patches of life. You could imagine them like moss growing on rocks. These are early subnets, small systems exploring different ideas, fragile experiments. Some of them disappear quickly, but some survive. And then more experiments appear: ferns, small plants, early species trying different approaches, different forms of intelligence, different services, different economic models. And slowly, the landscape begins to change. What once looked barren starts to resemble something else: a forest. Now, inside this forest, each subnet is like a tree. Some trees grow large, some remain small, some die out completely, but together they form the ecosystem. And just like in real forests, growth is not centrally planned. There is no committee deciding which trees should exist. Instead, the forest evolves through competition. Trees compete for sunlight, roots compete for nutrients. Some species adapt better than others, and over time, the forest becomes more complex, more diverse, more resilient. But tensor behaves in a surprisingly similar way. Subnets compete for something called emissions. Emissions distribute tau, the native token of the network, to participants who produce useful work. If a subnet becomes valuable, it attracts miners. Performance improves, and the subnet captures even more emissions, which allows it to grow even further. Just like a tree capturing more sunlight. And this is where the metaphor becomes especially helpful. Tau in the Bittensor ecosystem behaves a bit like sunlight in a forest. Sunlight provides the energy that allows plants to grow. Without it, the forest cannot exist. In Bittensor, tau emissions provide the economic energy that powers activity. Miners earn tau for producing useful outputs. Validators earn tau for evaluating those outputs. Subnets compete to attract activity that leads to more emissions. So the system is constantly redistributing energy toward what appears to be useful. But there's another interesting layer to this. Because tau isn't just flowing energy, it can also be stored. Think about how trees store energy in the form of wood, for example. In a similar way, the Bittensor ecosystem stores value inside its economic structures. Participants hold tau, assets get staked, subnets accumulate capital. And over time, the ecosystem begins to develop reservoirs of stored value. And those reservoirs influence how the system evolves. Now, there's another lesson we can borrow from forests. Diversity creates resilience. A forest with just one species might grow quickly, but it's fragile. A single disease can wipe out the entire ecosystem. Healthy forests contain many species. Some dominate the canopy, others stabilize the soil. Others perform small niche functions that become important only under specific conditions. The same logic applies to Bittensor. Some subnets may become large infrastructure layers. Others will specialize in narrow tasks. Both are important, because diversity makes the ecosystem stronger. Now let's shift metaphors for a moment. Instead of imagining a forest, imagine a planet. A planet covered with cities. Each city specializes in a different economic activity. One city focuses on manufacturing, another one on finance, another on research, another on logistics. And each city has workers, inspectors, businesses, markets. Trade flows between them. When you start looking at Bittensor this way, the structure becomes surprisingly similar. Because each subnet is like a city, a specialized economy inside the network. Some cities become small towns, some become huge cities, and some become ghost towns. Think about how real cities evolve. Some cities explode with growth, they attract capital, they attract talent, investment flows in, infrastructure expands, they become global hubs. Others never gain traction. Economic activity slows, people leave, buildings empty, and eventually they become ghost towns. The same thing can happen inside Bittensor. Some subnets may become extremely important. They attract miners. Developers start building applications on top of them. Economic activity grows. Those subnets become the huge cities of the ecosystem. Others might struggle. Maybe the ID isn't useful. Maybe the evaluation system doesn't work well. Maybe better alternatives appear. Activity slowly disappears. They fade away, ghost towns. And importantly, this is not a failure of the system. That's how ecosystems evolve. Inside these cities, there are also different roles. Workers produce outputs, inspectors evaluate quality, markets allocate resources. In Bittensor terms, these roles correspond roughly to miners, validators, and stakers. Miners produce the intelligence, validators evaluate it, and Tau functions as the shared currency connecting the economic activity across the ecosystem. We'll explore these roles in much more detail in coming episodes. But for now, the key idea is simple. Each subnet is a self-contained economic environment. Now, let's look at a few examples of these cities inside the ecosystem. One interesting subnet is called Shoots. Shoots focuses on decentralized AI compute. Think about how most people interact with AI today. When you use a large language model, such as a ChatGPT model, your request typically goes to servers owned by a single company. Your prompts move through centralized infrastructure. Shoots explores a different idea, running AI models across a decentralized network of GPUs, which could make it possible to interact with powerful AI systems. Imagine having private conversations with an AI assistant without one company owning the entire interaction or the model. That's the type of idea Shoots is exploring. Another important subnet is Hippias. Hippias focuses on decentralized storage. Hippias explores a distributed alternative. Storage provided by many participants across the globe, economically incentivized, and resistant to single points of control or failure. In an AI ecosystem, storage becomes extremely important. Data sets, model checkpoints, training results, all of that information needs somewhere to live. So storage subnets like Hippias play a foundational role. They are like infrastructure cities supporting the entire ecosystem. Another interesting example is video or video. Video focuses on video compression. Now that might sound like a small technical niche, but it's actually a huge challenge. Streaming platforms like Netflix move enormous amounts of information every second. Better compression algorithms can dramatically reduce bandwidth and storage costs. which means a subnet that improves video compression could provide real value to many different applications. And that's an important insight. Not every subnet needs to build chatbots. Some of the most valuable work may happen deep in the infrastructure layer. Another intriguing example is Yanes. Yanes focuses on identity simulation and testing. As AI systems become more sophisticated, questions about identity become increasingly important. Can digital identities be simulated? Can AI agents be tested in controlled environments? Subnets exploring these questions may become extremely relevant in a world where AI systems interact with both humans and each other. Now, here's one of the most revolutionary aspects of the Bittensor ecosystem. Anyone in the world can participate. Anyone. You don't need permission from a company. You don't need venture capital. You don't need to work at a specific organization. If you have the technical ability, you can connect your system to the network and start contributing. And this idea may sound familiar because we've seen something similar before with Bitcoin. Bitcoin introduced a radical idea, an open network where anyone in the world could participate in securing the system. No central authority, no gatekeepers, just a protocol and incentives. And that simple idea turned out to be incredibly powerful because open systems scale in ways that closed systems cannot. Bitcoin created the first global monetary network that anyone could join. Bittensor explores a similar idea, but applied to intelligence. Instead of an open network for money, it attempts to create an open network for machine intelligence. And more, actually. And if that idea works, even partially, the implications could be enormous, because intelligence may become one of the most valuable resources of the 21st century. Now let's return briefly to something we touched on in the previous episode: infrastructure. When new technologies emerge, they usually start as experiments, rough, messy, unstable. Then gradually they improve. Developers build tools on top of them, applications appear, and eventually the technology becomes infrastructure. Invisible but essential. Most people don't know what operating system powers their servers. Most people don't know how DNS routing works. Most people don't even realize that Linux powers enormous parts of the internet. They simply open an app and it works. And Bittensor might very well follow a similar path. Subnets may begin providing useful services: compute, storage, compression, verification, and other developers might build applications that use those services, resulting in cheaper end products, better infrastructure, new kinds of AI-powered tools. And the end users might never realize that the intelligence underneath these tools comes from decentralized subnet economies. That's what I call the infrastructure scenario. So when people ask the question, what is Bittensor? The best answer might not actually be technical. It might be something simpler. Bittensor is an economic ecosystem for intelligence. A network where specialized AI economies compete and cooperate, where incentives guide experimentation, where new services can emerge, and where anyone in the world can contribute. It's an ambitious experiment. It might succeed or it might fail, but it is one of the most interesting attempts I've seen to rethink how intelligence could be produced and coordinated. So, in the next episode, I'm going to zoom in again, because now that we understand the ecosystem, we need to understand the participants inside it. So, who are the miners? Who are the validators? How does the network decide who deserves rewards? And how does intelligence actually get measured? Those questions will take us deeper into the mechanics of the network. So, if you want to explore these ideas further, you can also visit my website discoverbittensor.com, where I write longer explanations about how the Bittensor ecosystem works. Thanks for listening, and welcome to the journey of discovering Bittensor.